Okay, before we get started here, let's just take a look at recursive versus explicit. Okay, so what does recursive mean? Recursive means previous. So this one is not as powerful as explicit. Sometimes you might have a formula using previous notation. For example, if this is the term, then a sub n minus 1 is the previous term. And it helps to maybe say it in English so you know what to do. Okay, now the more powerful one, and the one that we always use, let's put a star by it, is explicit. Explicit uses the first term. And this is the one we're always going to go with. Here's a couple of examples. Okay, first of all, do you know the arithmetic explicit term? So a sub n equals. Same thing for geometric, a sub n equals. Now in both these cases, explicit uses the first term. So a sub 1, a sub 1. Now when I say arithmetic, you say to add. Okay, then I'm going to add. I'm going to add on some d's. How many d's? N minus 1 d's. Now when I say geometric, you say to multiply. Okay, you betcha. I'm going to take a1 and I'm going to multiply by some r's. How many r's to get all the way to number n? To the power of n minus 1. Okay, then we learned some finite sum formulas. And you definitely have to have these memorized as well. So the finite sum is s sub n. That's how many things we're adding, s sub n. Now both of these formulas have a fraction bar. Okay. The finite sum for arithmetic starts with n, but the finite sum for geometric starts with a sub 1. Okay, there's a little difference there. Now in parentheses for arithmetic, it's first plus last. A number 1 all the way to a number, whatever that n is, a sub n. First plus last over 2. The finite sum for geometric was a little fancier. 1 minus r to the n power, and sometimes it helps to put r in parentheses. So the r is the only thing getting the n power. Do not put it out there. And in the bottom, it's just 1 minus r. Okay. Find a simplified explicit formula if they give you two terms. Okay, when they give you two terms means make a system. Make a system. Okay, so we're going to have to write some formulas for a term, for an arithmetic term, for a sub 2. Well, a sub 2 is a1 plus how many d's? 1d equals negative 101. A sub 10 is a1 plus how many d's? 9 d's, and that's negative 13. And so you've just made a system. Now it's time to solve that system. You could do elimination, multiplying everything here by negative. You can use your program. However you want, please solve this arithmetic system. And so what we're looking here, we're looking for a sub 1 and we're looking for d. So I hope you can solve this. A sub 1 is negative 112, and d is 11. Okay, now you need to know those two things to write an explicit formula. So for this example, a sub n equals, you always write down a sub 1, negative 112, plus n minus 1, and d is 11. Let's go ahead and simplify that. Distribute. 11n minus 11 minus 112 is minus 1, 2, 3. Now, remember, if you're going for an A on the test, then you're going to want to test your formula to see if that is indeed the correct formula. So what I'm going to do here with my calculator is take 11 times, let's see if the second term comes out to be negative 101 minus 1, 2, 3. Great. Let's try again with 10. I'm going to take 11 times 10 minus 1, 2, 3. Perfect. It's making the 10th term. And what did they want me to find? The 17th term, not a problem. All I have to do to find the 17th term is take my formula, plug in 17 minus 1, 2, 3, and the answer is 64. Okay, now we'll do a little bit of review here on the geometric side. I see two terms, so again, we're going to make a system. So we need to make a formula for a sub 5. So that's a1 times r to the power of 4 equals 405. Let's make an equation for a sub 9. How do you make a formula for a sub 9? Well, it's a1 times how many r's? 8 r's equals 32,805. Here's the geometric system. How do you solve a geometric system? You can't use the program and you can't use elimination. So what you do is you divide the two of them. You make ratios. Make two ratios. Everything's going to cancel, and so we're going to get 1 over r to the 4th. Over here, you can cancel by hand, or remember, your calculator can cancel for you. 405 divided by 32805, math fraction, reduces, oh, that's nice, to 1 over 81. Cross multiplying might be a good idea. R to the 4th equals 81. Especially when it's fractions and stuff, it just kind of cleans it up a little bit. And you have to take the 4th root. The 4th root. Some people take the 4th root. Some people raise to the 1/4 power. Some people just know this answer. R is going to be 3. Now you're halfway done. We have to find the other variable in our system. We found r, but now we have to find a sub 1. I'm going to use this top equation because it's a little smaller. So a sub 1 times 3 to the 4th power is 405. So a sub 1 must be, and the right answer is 5. Okay, those are the two things we need to know to write an explicit formula. For this sequence, you need to know r and a sub 1. So let's start by writing a sub n equals a1, which is 5. R is 3 to the power of n minus 1. But of course, we have to simplify that a little bit. So how many people are really good at taking that 3, flipping it over, putting the 3 under the 5, and saying 5/3 times 3 to the n? I want to make sure that I do indeed have the correct formula. So I'm going to go ahead and take 5/3 times by 3 to the power of 5. I want to see if 5 makes the right answer. Good, it's making the 5th term. Let's try again. Second, enter, and I'm going to test 9 to see if it makes the 9th term. Excellent. Now I know I must have the correct formula. I can very easily find the 17th term by taking that, second enter, and changing 9 to 17. Whoa. 1, 2, 3, comma, 1, 2, 3, comma, 215,233,605. That is the 17th term. Okay, that was just a quick review of all the formulas you've learned so far. Now it's time to do something a little different. Okay, so today we're going to look at infinite. Infinite means that doesn't stop. And geometric series. Okay, so infinite means it does not stop. Geometric means that there's going to be an r, you're going to be multiplying, and series means sum. Okay, there's two things you have to learn here. The first thing is converge. Converge means to get smaller and approach a number. Diverge means to get larger and larger and larger and larger. And so you're not going to approach a number because you're just going forever. Okay, example, 1 plus a half plus a fourth. See how they're getting smaller, 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 closer and closer and closer and closer, and then almost getting to 0. But here, 5, 10, 20, dot, dot, I mean, that's just going forever. So how do you know if something's converging, getting smaller, or diverging and getting bigger? Well, you're just going to look at the r value. The r value here, each one is half. That's going to make them smaller. And here, the r value is 2. And that's going to make the numbers get bigger. Okay, so here's the rule. It's going to converge when the absolute value is less than 1. It doesn't matter if this is a negative or not. Negative still makes smaller, smaller, smaller numbers. Okay? So when r is less than 1, you can sum it. And the formula is a sub 1 over 1 minus r. Well, that formula is very, very familiar. It's kind of like the geometric sum formula for a finite sum, except, oh, where's the n? Did I forget to type an n? No, I didn't forget to type an n because the series is forever. It's infinite, so you don't put an n. If it's a finite sum, you put an n. That's why. And then here, notice the part up here that has the n is missing. So it's the same formula as we learned, except the parts with n are gone. So a formula is really small. Now what happens if it's diverging and it's getting bigger, 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 bigger? Diverging, okay, this means more than 1. More than 1. Plus or minus. Okay, it could be a negative 2, and they could be getting bigger, bigger, bigger negatively. So how do you add something? You don't. You just stop. So if you have converging problems, please calculate them. If you have diverging problems, please don't do anything. All right, let's take a look at this first one here. Okay, 1 plus a half plus a fourth. We said that that was converging. Okay, so we said that this was geometric. A1 is 1, and the r value was a half. Since r value is a half, okay, that means it's converging. And we also have to think about if it's finite or infinite. Since it's going forever, it's infinite, which means we can add it. So we're going to use the formula a1 over 1 minus r. a1 is 1. 1 minus the r value is a half. 1 minus a half is a half. Multiply top and bottom by 2, or bring that up, and the sum is 2. So the sum is going to make a 2. If it goes forever, forever, and you get all those numbers put together. Kind of weird. Okay. I'm noticing here that it goes forever. So there's a couple of things we have to do. Let's make the series. Let's make all the terms that are being added so we can see what we have. And then I'm going to ask you all the questions about it. So first, let's put a 1 in. Half of 4 is 2. Okay, let's put 2 in. 4 times 1/4 is 1. Let's put 3 in. That's 1 over 8. 4 times 8 is a half. Okay, now let me ask you, is that enough for you to notice the pattern? You usually have to do 3 or 4 terms. If you can see the pattern, if you can see what's happening here, then you can kind of jump ahead to infinity. So dot, 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 forever. Okay, so here's the questions I need to ask you. Is this geometric or arithmetic? Geometric, okay. If you say geometric, then you have to tell me what r is. R is a half. Okay, now I know that we can add this. Is it finite or infinite? It's infinite because it goes forever. Okay, now you could only add geometric infinites if they converge. Does this converge or diverge? Since the r is a half, it converges. Okay, that means we can do this. We can find the sum. The formula is a1, 2 over 1 minus a half. And so 2 divided by 1/2 makes a 4. So S is 4. Excellent. Okay, let's look at this next one here. Oh, they've written out for us, so we just have to study this. Are they adding, 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 or multiplying? Is it arithmetic or geometric? I think it's geometric. Okay, so what's the R value? It's definitely negative. The numerator is getting times 3 times 3 times 3, okay. And the denominator is getting times by 2. Okay, so there's your R value. Is this finite or infinite? This is infinite. Okay, now if it's geometric infinite, you can add it, but I have to ask you one more question. Does this series diverge or converge? And the answer is diverge. How do you know that? Diverge because that is more than 1. And you don't care about the negative. You just look at the absolute value. 3/2 is definitely going to make these get bigger, bigger. So I cannot add it. So don't do any work. Okay. Number 3. Let's see what's happening here. Okay. Sometimes when the problems are tricky like this, I like to take the second term and divide by the first term. Dividing the terms is the best way to figure out the r. So -4 radical 2 divided by 8 is negative radical 2 over 2. Let's see, is that true? Let's take -4 rad 2, multiply it by r, negative radical 2 over 2. The negatives cancel. 4 and 2 cancels. That's 2 times 2, which makes 4. Yep. And then just 4 times that. Okay, so I figured out r, and there it is. So this problem is geometric. Here's the r. Is it finite or infinite? It's definitely infinite. Okay, now I have to ask you converge or diverge. Is this number, don't worry about the negative, is it more than 1 or less than 1? Some people know what radical 2 over 2 is just from unit circle. Radical 2 divided by 2 is 0.7. That's less than 1, so this problem converges. So we can add it. Okay, let's use our formula. S equals A1, 8, divided by 1 minus r, which is negative radical 2 over 2. Okay, let's do change right there. Ooh, this kind of looks like chapter 7. Let's change 1 into 2 over 2. In fact, let's change 8 into 16 over 2. So we're making a lot of 2's. This is good review for the final. All those denominators are going to cancel, and now we have 16 divided by 2 plus radical 2. Of course, we can't leave it like that. You were going to say, do we have to rationalize? Of course we're going to rationalize. Put some parentheses, and you have to multiply by the conjugate. By the conjugate. So the conjugate at the bottom is 2 minus radical 2. 2 minus radical 2. Okay, so in the numerator, let's distribute and make 32 minus 16 radical 2. In the bottom, a difference of squares. All I really need to worry about is firsts, which is 4, minus lasts. Radical 2 times radical 2 is a plain 2. And so now we're at the point where we have 32 minus 16 radical 2, and the denominator is 2. Who's going to get the 2? Well, each of them will get the 2. So the sum of all these radical numbers is 16 minus 8 radical 2. Look at that. Great review of radicals. Keep some chapter 7 stuff fresh for us. Okay. A pendulum swings through an arc of 18 inches. Okay, so the first one's 18 inches. And each successive swing, the length is 0.98 of the previous length. So let's take 18, and I'm just curious, what is 18 times 0.98? Oh, so the next one is only 17.64 inches. And then the next one after that is going to be 17.2872 inches. Okay. When it stops, what is the total distance? So first of all, is this arithmetic or geometric? Because I keep multiplying by 0.98. Geometric, and the r is 0.98. Okay. It's going forever, forever, forever. It's just going to keep swinging, swinging, swinging until gravity stops it. So does it stop after the 10th, the 11th? No one really stops it. It can go as long as it wants. So in theory, we're not going to stop this. We're going to let it swing forever. Well, of course, it's not going to really go forever because gravity is going to stop it. But it can go little, little, little. And maybe it's so little the human eye can't see it. So the idea with this problem is that it is infinite. We're not going to stop it. We're going to let it go forever. Since it's geometric infinite, look at the R value and tell me if it's converge or diverge. Less than 1, it's going to converge. So of course we can add this. The sum is A1, 18, over 1 minus R, which is 0.98. 18 divided by 1 minus 0.98 is 900 inches. Make sure you use some units. Okay, so if it goes forever and it's arithmetic, can't do it. If it goes forever and it's geometric, half the time you can and half the time you can't. Okay, this lesson was on infinite geometric series. If it's infinite and arithmetic, we cannot do it. And only half the time with geometric. Great lesson, everybody.